Hello everyone and welcome to my pre-class video for 13.2. Here we are. Hope your quiz 2 is going well and that you score high and all that good stuff. 13.2 and kind of chapter 13 as a whole is where you start to see some of the curriculum changes take effect. And I know I've mentioned this in some previous videos, but I'll just reiterate here in case you missed it. Right, there's a little bit of rearranging done in order to get some of the more difficult stuff in Math 234 kind of on the front end. There's a lot of difficult stuff on the back end of Math 234, and so it's been a general push for a while now to try to equalize things a little bit. And so one of the things that we're going to be seeing is that parametrizing surfaces, which are these sections right here, are coming earlier, right? You see that there's chapter 16, right? 16.6 intro here. And this is really, it belongs to chapter 15 or so, an introduction to cylindrical and spherical coordinates. So that's going to be coming considerably early and, helping you parametrize surfaces. Right before that, you get parametrizing curves, 13.1. So you can see that we've rearranged things a little bit. Parametrizing curves takes a little bit of effort, certainly. And so we've backed that up and have it right next to parametrizing surfaces. So that's kind of how chapter 13 is going to be ending. 13.4 is an application section. As you can see here, motion in space, velocity, and acceleration. And so the classic kind of throwing balls and when do they hit the ground and when do they meet a maximum height and all that sort of stuff, but now in vector format with 2 or 3 dimensions. And then finally 13.2 is what we're coming up on here. This one we're assuming that we already have a parametrized curve and we want to ask, well, some calculus questions, right? Maybe, right, it's been a while since we had calculus, right? Chapter 12, there was no derivatives, there's no integrals, anything like this. I'm sure you guys are hungry for calculus, and that's what we're going to be doing here in 13.2 with vector curves. And so maybe the first thing that I want to do here is just kind of show you what a vector curve looks like. And so I'm over here in the Monroe 3D calc plotter, and I've graphed, in fact, if you just select that you want it to do, so instead of a vector curve, it calls these things a space curve, still R of t here. So if you tell it that you want it to graph a space curve, this is what it just came up for me. So it just got one of these. You can see it's sort of a spiral thing. Now with any of these vector curves, similar to lines, really the curve itself is the tracing, or it's kind of the accumulation of these terminal points for lots of vectors. Remember, these are vectors. They're vectors that emanate out of the origin, and this is where they end. And so let me just hit animate, right? So right now, this is at time 10. So if you were to plug in 10 for all of these t's, this is what you would get. And you can move this slider here. Maybe now we're back down at -10. And we can just see that kind of this forms a sort of spiral here, which makes a lot of sense with the sines and cosines, right? So we have a cosine, we have a sine, so we know it's going to be going around in a circle, but now our z value kind of steadily increases. So this is going to make a spring sort of deal. And so this is what one of these space curves or vector curves is, right? Again, it's this accumulation of points, and you can ask all sorts of fun questions. Like, what's the velocity, right? If you were actually, at this point, kind of writing this curve, right, you could ask, how fast are you going? What's the velocity at that point? Or you could ask, what's the speed at that point, right? You could ask things about acceleration. You could ask things about, again, maybe when does it hit the ground? When does it hit maybe like z equals 0 over here? And then, right, when is maybe going to be answered with a time value. You could ask, how long is this curve, right? Like if you were to, add up all this length right here, how long would this curve be, right? If we were to make this as, a roller coaster track or something like this, how much track do we need in order to build that? And so these are some of the questions that we're going to be answering in chapter 13. Related to that, I know it's come up a few times on Piazza, but I thought it's good as time as any to do a old shameless plug here. A while back, so I guess in spring 2019, maybe even before this, I purchased some domains here and there. They're ridiculously cheap, like $15 a year or something like this, and I've kept this one up. So I own mth234.com, right? And this is it here. And I have posted back from then A lot of this is just nonsense. You know, these aren't updated by any means. I just haven't changed it at all. But there are some useful things here. For instance, I have my old notes. So for instance, you know, any of the chapter 12 stuff that we're just finishing up on, I have some blank notes. And you can see when I was teaching this class on my own here, I had kind of some pre-class videos. So videos that I wanted students to watch before coming to class. And then of course we did some stuff in class, right? And of course, the stuff that's in class, you know, it was a live lecture and we didn't record it or anything like this. But there are some videos here that you can have access to if you'd like to watch those ahead of time and kind of some notes. And then I posted what we did in class. So, right, even though there's not a video and there's not, you know, my beautiful words and all that sort of stuff, there is at least kind of filled out notes. And then of course, I'm happy to talk about these sorts of things or any of your class notes. I mean, it certainly doesn't have to be these ones, but any of your class notes during office hours. I've been having some good office hours. You know, probably what, 4 people came today, maybe 5 or 6 came on Monday's class. But, you know, kind of people have been, you know, sorry, Monday's office hours, but kind of people have been trickling in and just asking like one question and then leaving. I really would like it to be a space where you guys can just come and hang out. Even if you don't have any questions, you can just kind of work on your web work or whatever, or study. And then just as other people ask interesting questions, maybe you can listen if it, you know, piques your interest and ignore them if it doesn't. And so anyway, those are just a couple of thoughts. And again, kind of, you know, shameless plugs here as far as if you ever need more resources, this is an excellent place to go, I think, or at least a mediocre place to go, right? And here's 13.2, right? So you could watch a pre-class video if you'd like, where I actually spend a little bit more time going into some in-depth stuff. Let me just go ahead and click on this, 13.2. Now, again, the ordering on this is changing, right? And so this is a bit outdated, but maybe you can jump around, and I'm certainly you know, willing to help if you have any questions with these. So yeah, we can kind of go in. This pre-class video talks to you about how to take derivatives of vectors, how to do integrals of vectors, how to do limits of vectors, all that sort of stuff. And so you get a 13-minute kind of pre-class video if you'd like to get into kind of some specific problems. All right. I think that's about it for me for today. I hope you guys enjoyed. And if you have any questions, please come visit me in office hours or post them on Piazza. All right. Take care.